In this chapter, we've looked at several methods for solving systems of equations. Again, it's up to you to choose whichever method you'd like. Choose the one that works easiest for you. Let's look at our first system. In this system, we have 7x plus 6y equals 45, and 6x minus 5y equals negative 2. Since none of the variables are alone or by itself, I'm not going to choose a method called substitution. I'm going to choose the addition method. But even the addition method poses a bit of a problem here, because I can't multiply either of the equations by a single number and get the equations to add together and drop out a variable. So I'm going to have to multiply both the equations by a number. Now, I have to choose, do I want to eliminate the x's or do I want to eliminate the y's? Here's how I make my choice. I simply look at the coefficients 7 and 6. I look at the coefficients 6 and 5. Since I like to use smaller numbers, I'm going to choose to eliminate the y's. Now, to eliminate the y's, I have to look for a number that I can multiply each of these by, so that when I add them together, they'll cancel each other out. If this 6y were a 30y, which I could get by multiplying by 5, and then if this negative 5y were a negative 30y, which I could get by multiplying by 6, when I add those together, my y's would drop out. So that's what I'm going to choose to do here. Again, I'm going to multiply this top equation by 5. When I do, I'm going to get 7 times 5, or 35x, plus 5 times 6, there is my 30y, and that's equal to, I've got 5 times 45, or 225. Now, my second equation. My goal again is to eliminate those y's. I want to make this a negative 30y. So I can do that by multiplying the second equation by 6. Multiplying the second equation by 6 gives me 6 times 6, 36x, minus, there it is, 6 times negative 5 gives me my negative 30y, and that's all equal to 6 times negative 2, which gives me negative 12. Now I'm ready to add my two equations together. Adding these two together give me 71x, 30y, and negative 30y give me 0, and I get here 225 minus 12, or 213. Now to solve for x, all I have to do is divide both sides by 71. When I do, I get x is equal to 3. Now that I have x equals 3, again, I know you're familiar with this method. We're going to take the 3, substitute it into either one of these two equations, and solve for y. Since I don't really like that 45 too much, I'm going to take the x and substitute it into that second equation. When I do, I get 6 times 3, 18, minus 5y is equal to negative 2. Subtracting 18 from both sides gives me negative 5y is equal to negative 2 minus 18, negative 20. Finally, dividing both sides by negative 5 gives me y is equal to positive 4. So what does this mean? This means that for this system of equations, my solution is the ordered pair 3, 4. Now, what does that look like geometrically? What that means is if I were to graph each of these equations on the same coordinate plane, let's say that this was one line, and here's my other line, that this point of intersection would be our point 3, 4. In other words, this point 3, 4 lies on each of my lines, which is why it makes each of these equations a true statement. Again, what I call this when I have a solution, or at least a solution, to my system, I say my system is consistent. Not too bad. Let's try another system. Let's look at the following system. And again, as you're working through these systems of equations, just choose the method that you like best. So let's look at this time the equations, 4x plus 2y equals 2, and our second equation, minus 6x minus 3y is equal to 6. Now again, it's up to you which method you like to use. Substitution or addition, you choose. In a way, I'm partial to addition unless a variable is all by itself, in other words, with a coefficient of 1. So since I don't have that in this case, I'm going to again choose to use the method that we call addition. Again, I look at my two numbers and I decide which ones should I eliminate. Again, I choose y's. Why? Because the numbers are smaller, for no better reason than that. So I ask myself, what numbers can I multiply these by so I get a positive something y and a negative something y? If I can make this a positive 6y and this a negative 6y, that would add up to 0. So here I go. I'm going to multiply the top equation by positive 3. So when I do that, I get here 12x plus 6y is equal to 6. Again, don't forget, multiply both sides of the equation by the number that you choose. Since we're eliminating the 6y, we want to make this a negative 6y. We're going to multiply our second equation by 2. This gives me here negative 12x plus 6y is equal to 12. Now that we've done that, and again, work carefully when you're doing your multiplication, because any small error in arithmetic could throw the whole problem off, we're ready to add our equations together. You might be saying, this one looks odd. 12x minus 12x, that's 0. 6y plus, oops, we have a little problem here, so I'll add it in now. I notice that here, this was a negative 12x, and this here is a negative 6y. So I just added in that negative sign, again, being very careful with your signs. So again, I have 12x and negative 12x, that's 0. I got 6y and negative 6y, that's also 0. So on the left-hand side of the equation, not only did I eliminate my y's, but at the same time, I eliminated my x's. So what do I have here? I get 0 equals, on the right-hand side, 6 plus 12, 18. What does that mean? 0 equals 18? That's not true. That's a false statement. So we say here, false statement. And what does that mean when we get a system of equations to equal a false statement? What that means is there is no solution to our system. Now you might be asking yourself, what does it mean to be no solution? Let's think about this geometrically. If there is no solution, that means that our two lines, when they're graphed, have no points in common. So in other words, our lines are parallel to each other. So if I were to draw the graph of both of those lines, it would look something like this. The lines parallel to each other having no point of intersection, meaning there is no ordered pair that will make both those equations true. Since there's no solution, I call my system inconsistent. And that means the same as having no solution. All right, so this is a very different result. Let's look at our last example here. In our last example, we're going to see if we can come up with yet another surprising result. Let's look at the following system. We have 3x minus 9y equals 18, and negative 4x plus 12y equals a negative 24. Now, in this system again, you choose whichever method you're comfortable with. I'm partial here to addition only because neither of these is solved for, has the coefficient of 1. So which one will I eliminate? I'll probably eliminate the x's again. Why? Because the coefficients are smaller. I'm going to probably try to make this a 12x and the bottom one a negative 12x. So here we go. I'm going to multiply this top equation by 4. When I do, I'm going to get here 12x minus 36y, multiplying everything by 4, is equal to the right-hand side 72. The second equation, again, I'm going to multiply by 3, which gives me here negative 12x. 3 times 12 plus 36y is equal to, on the right-hand side, 3 times negative 24 gives me a negative 72. Now let's see what results we get. When I add the left-hand side together, 12x minus 12x, 0. Negative 36y, positive 36y, 0. On the left-hand side, I got 0. On the right-hand side, I have 72 and a negative 72. That's also 0. 0 equals 0. I didn't get a value for x or y, but I got a true statement. So what does that mean when I get a true statement? It means that there are an infinite number of solutions. Infinite number of solutions. What does that mean? That means there are an infinite number of ordered pairs that will make these two equations true. Now, what does that mean geometrically? It means that if I graphed one of my lines, and then I graphed my second line, guess where the relationship of those two would be? My second line would be exactly on top of my first line, so that every single ordered pair on that line would be a solution. So again, since I have at least one solution, I call the system consistent. I hope you recognize that there are 3 possibilities when you're solving these systems of equations. 1, an ordered pair, meaning the system is consistent. 2, you get a false statement and there's no solution. And 3, a true statement means there's an infinite number of solutions.